Hello, today we're going to be looking at shapes of graph notes. So let's take a look at example 1. Determine whether each function has line symmetry. Explain. So what line symmetry is we can draw a line down one part of the graph and the left side will match what's going on the right side of the graph. And if we look at our first example, example 1, we notice we got this V kind of thing going on. So if I draw a line right here, the left side of my graph is going to look like the right side of my graph. I can basically fold it over at this point and it'll match up. So this has line symmetry, and the point that it has line symmetry at is x equals -1. So yes, we have line symmetry at x equals -1. So that's how you do the first one. Now let's take a look at the second one. So going from left to right, if you notice, it just keeps going down, 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 down. So there is no point where one side looks like the other side. It just keeps getting lower and lower and lower. So this is just going to be no. And that's it. There is no line symmetry. Does not have line symmetry. All right, let's take a look at example 2. So example 2, what we want to do is we want to determine, does this graph that we have here have line symmetry? And if we look at it, we see that it starts going up, and then at one point it kind of gets to the top part, and then it starts coming back down. So this one also has line symmetry. And the part where it kind of stops going up and starts going back down is right here. And this point is at 5. So it has a line of symmetry. At x equals 5. Again, line symmetry at x equals 5. So the first two examples, we're dealing with line symmetry. The next thing that we're going to look at is we're going to look at where these values are increasing and where these values are decreasing. So the way we look at it is we look at in terms of the x. So we're going to look at the two parts of the graph. So we're going to look at the left part of the graph, which is where the x values are negative. And we're going to look at the right part of the graph where the x values are positive. So the left part of the graph, for number 7, in example 3, you'll notice that it is coming down in that left part of the graph. So the function is decreasing. Is decreasing for x less than 0. So those are my negative values. Now, if we look at the right side of the graph, again, the function is still decreasing. So the function is decreasing for x is greater than 0. So those are my positive values. So on the left side where it's negative, the function's decreasing. And on the right side where the x values are positive, the function is also decreasing. Let's take a look at number 8. So number 8, we kind of got a weird thing that's happening in number 8. With number 8, the function is decreasing, then it bottoms out, and then it starts increasing. So where it's the shift, it's right here. So we're going to use that as kind of like determining where it's increasing and decreasing. And that point right there is at x equals 2. So the function is increasing for, again, it's going up over here, so those are going to be values greater than 2. Now it's decreasing for values less than 2. The function is decreasing for x less than 2. So increasing when x is greater than 2, decreasing when x is less than 2. So let's keep going on with this idea of increasing and decreasing and looking at shifting. And the next thing that we're going to look at is extremas, and then we're going to identify relative maxes and relative mins. So extremas are shifts that are happening in the graphs. So where are we kind of topping out or bottoming out in our graph? So for example, for number 11, we have some extremas. So these are happening at point B and D. B and point D. So these are where we got something happening to the graph. So either it's going to be maxing out or it's going to be bottoming out, minning out. And so if we look at the first one, a relative max, that means there's nothing higher than that point with respect to the graph. Relative max. And if we look at our graph, this point B right here, there's nothing higher than it around it. It's the top part with respect to that spot. So point B is a relative max. Now relative min. Relative min is where it bottoms out on the graph. So if I look at that, there's nothing lower than that point, and that's going to be right here at point D. So that's what we have for that. So B is the top part of it. B is the bottom part. There's nothing lower than B. Now let's take a look at 12. So with 12, again, we want to identify what our extremas are. Where are points where it's going to be bottoming out or it's going to be topping out? So those points are going to be point A, point B, and point C. So those 3 points are our extremas. Now we want to determine, is it a min extrema or is it a max extrema? So relative min min. This needs to be an N. So that means there's nothing lower than that. Those are the lowest parts. And if you look at this, A is a min, C is a min. There's nothing lower than that. So point A and point C. So those are our mins. Nothing goes lower than that. After those, it starts coming back up. So relative max so nothing goes higher than this point, and that's going to be B, because A, it turns around, starts going up. B, it then turns around, starts going back down. So point B is going to be a relative max. So extremas dealing with relative mins, relative max, what's happening at that point of the graph. So we looked at positive and negative, we looked at extremas. Now we're going to be looking at end behaviors. What's happening outside of the graph, these arrow parts. So this part, this part, this part, this part. What's happening in the long term of this graph? So these are determining the end behaviors. So let's take a look at the first example. So if we look at this, we're starting like way up here, and then we come down, and then this would be our relative min down here, and then we start going all the way back up. So as you move to the left, so as we're moving to the left of this graph, on the graph, y increases. So thus, as x decreases, y increases. All right, so that's going to the left. What happens if I go to the right? Well, same thing. As I go to the right, y is also increasing because we're bottoming out right here, which is very early. But if we keep going, again, this is end behavior. Keep going, keep going, keep going. We're looking at that spot right there. As you move to the right, on the graph, y increases again. Thus, so thus is basically summarizing it up. As x increases, y also increases. And if you look at it, it's this U that comes down and then goes up. But again, we're looking out from that center spot as we go further and further into the negatives. We're going higher and higher up. Further and further into the positives, we're going higher and higher up. All right, number 19. Number 19 is different. Number 19, if we keep going to the left, we're going to keep coming down. If we keep going to the right, we're going to keep coming up. So let's write that out. As you move to the left on the graph, y, so again, to the left, y is coming down this time, y decreases. Thus, as x decreases, y decreases. So as we go to the left, it keeps coming down. Now let's take a look at the right. If we keep going towards the right, so if we keep going this way, it's going up and up and up. So as you move to the right, on the graph, y increases. So again, summarize this all up. Thus, as x increases, y increases as well. So we're looking at the end behavior, what's happening as we get into smaller and smaller x's and bigger x's. What is happening to our y? Is it getting smaller values or is it getting bigger values? So over this video, we went through determining line of symmetry. We went through increasing or decreasing. We went through extremas, looking at certain points on the graph, basically our turnaround points. And then we also talked about what's happening in the long run, in the end behavior, as the graph keeps expanding out. So summarize these 4 ideas at the bottom, and then you're going to use these notes to help you with the practice problems.